Let's see some questions on trees and forest. This tree comma forest, these two concepts we have already seen. What is a forest? This is acyclic graph, graph without cycles. And what is tree? This is a connected acyclic graph, connected graph without cycles. So this is the difference between tree and forest. Forest can be disconnected, but tree is always connected. Every tree is forest. So these concepts we have already seen. Now let's start. So this is the first. What is the maximum number of edges in a forest on n vertices? What do you think? What is the maximum number of edges in a forest on n vertices? What will be the answer? You have a forest in which you want to find maximum number of edges. So the answer will be what? Answer will be n minus 1. Because you have a forest. For example, if I give you these four vertices, I want to create a forest. Then tell me maximum how many edges I can add. Maximum how many edges I can add. I want a forest. Tell me, I want a forest. So maximum how many edges I can add. I can add this edge. I can add this edge. I can add this edge. Can I add this edge? Tell me, can I add this? No, because I want a forest. If I add this, then there will be a cycle. There will be a cycle. So I cannot add. So maximum how many edges I can add? If I have four vertices, I can add this edge, I can add this edge, or I can add this edge. Can I add this edge? No, there will be a cycle. Can I add this edge? No, there will be a cycle. So maximum how many edges I can add in a forest on n vertices? I can add n minus 1 edges. These are the maximum number of edges in a forest. And forest with and what is this? This type of forest, what do we call it? This type of forest, what we call it? That is a tree. That is a tree. So I can say forest with maximum number of edges is a tree. Yes or no? So this is the idea. Forest with maximum number of edges. What is that? So this is a note. So what is the answer? Forest with maximum number of edges. Forest with maximum number of edges. Number of edges. Forest with maximum number of edges. Forest means acyclic graph. Acyclic graph with maximum number of edges. Okay. So acyclic graph. Acyclic graph with maximum number of edges, that is same as tree. So tree is basically maximally acyclic. I can say this is maximally acyclic, maximally forest. So this is maximal forest. I can say this is a maximally forest. Okay, this is clear. The first question. So in a forest, this is the question. What is the maximum number of edges in a forest on n vertices? So if you put maximum number of edges in a forest, then what you will get? You will get a tree. So finally, I can say forest with maximum number of edges, that will be a tree. That will be a tree. Okay. So very simple. And so I can say the tree is maximally acyclic. This is a maximally acyclic. Now let's see this question. What will be the answer? The maximum number of edges in a forest which is not a tree. Maximum number of edges in a forest which is not a tree. In a forest which is not a tree. So that will be n minus 2. Correct? N minus 2. Because see, if you have n minus 1 edges, okay, if you have n minus 1 edges, if you have these many edges, then it will be a tree. Then it will be a tree. Then forest will be a tree. I can say if n minus 1 edges, then forest will be a tree. Then forest will be a tree. Okay, so if I want a forest which is not a tree, this is what I want, a forest which is not a tree. Okay, so what is the maximum number of edges you can have? That will be n minus 2. Very simple. Next, what is this? What is the minimum number of edges in a connected graph on n vertices? What is the minimum number of edges? This is the question. I want minimum number of edges in a connected graph. So you have a connected graph and I want minimum number of edges. Then what is that? The answer will be n minus 1. Because you have a connected graph. For example, you have 4 vertices. I want a connected graph with minimum number of edges. Remember, I want connected graph. So I will connect like this. I want connected graph. So I will connect like this. Is this fine? So can I say this is correct? No, I want connected graph. Remember, you want connected graph. So with minimum number of edges. So now this is fine. Now this is fine. So minimum 3 edges you need. Correct? Minimum 3 edges you need. A, B, C, D. You can connect this edge. You can connect this edge. You can connect this edge. Okay. So minimum 3 edges you need. So minimum number of edges in a connected graph, that will be n minus 1. And this type of connected graph with minimum number of edges, this is called what? This is a tree. So this is a tree. And you know that what is a tree? This is tree. I can say tree is basically a connected graph with minimum number of edges. This is a connected graph with the minimum number of edges. With minimum number of edges. Okay. So I can say this is minimally connected. This tree is a minimally connected. Minimally connected. Okay. So very simple. This is minimally connected. Next, what is the answer for this question? What is the minimum number of edges in a connected cyclic graph? In a connected cyclic graph. So the answer will be now n. Because if you have a connected graph with n minus 1 edges, connected with n minus 1 edges, then what is that? See, connected with n minus 1 edges. If you have connected with n minus 1 edges, this you already know. Connected with n minus edges, that is same as tree. Connected with n minus 1 edges, that is tree. So if you want a cyclic graph, then you need n edges. These many edges you need, correct? Yes or no? Clear? Very simple. Because if you have connected with n minus 1 edges, if you only have n minus 1 edges in a connected graph, then it will be a tree. So if you want cyclic connected, then the number of edges, minimum number of edges should be n. Next, what is the answer for this question? What is the minimum number of edges in a connected acyclic graph? Minimum number of edges in a connected acyclic graph. Connected acyclic, this means tree. Connected acyclic means tree. So the answer will be n minus 1. Okay, because connected acyclic is tree. What is the answer for this question? Is it possible? So for this question, answer will be no. Because if you have a tree on n vertices, you know that if you have a tree with n vertices, then number of edges will be n minus 1, and total degree will be what? Total degree will be what? That will be twice of number of edges, that will be 2n minus 1. Okay, that will be 2 into n minus 1. So here you have tree with n vertices and the sum of degree is 18. This is not possible. So for n vertices, okay, for number of vertices equal to number of vertices is equal to 9. Okay, I can say total degree should be what? In a tree, total degree should be what? That should be 2 into 8. So that should be 16. So this is not possible because you have a tree. In a tree, if you have a tree on n vertices, 9 vertices, then total degree should be 16. So this is not possible. So the answer is no. This is not possible. What about this one? A graph, is it possible? A graph with 9 vertices, 9 edges and no cycles. So remember, first of all, no cycles means what? No cycles means forest. No cycles means forest. You already know. No cycles means forest. So the question is saying, is there any forest with 9 vertices, 9 edges? Is there any forest? In a forest, what is maximum number of edges possible? In a forest, what is maximum number of edges possible? In a forest, maximum number of edges that is possible is n minus 1. So the maximum number of edges possible is actually 9 minus 1 equal to 8. So we don't have any such forest. Yes or no? So this is possible. The answer is no. This is not possible. Because remember, no cycle means forest. So is there any forest with 9 vertices, 9 edges? We don't have. Because in a forest, the maximum number of edges will be n minus 1. Yes, minimum number of edges will be 0 in a forest. In a tree, what is minimum number of edges possible? Tell me, in a tree, what is minimum number of edges possible? In a tree on n vertices. In a tree on n vertices, you have a tree on n vertices. Okay, then what is minimum number of edges possible? What is maximum number of edges possible? So if you have a tree, then minimum number of edges is also n minus 1. This is also n minus 1. Because tree on n vertices, that automatically implies tree on n vertices, that automatically implies n minus 1 edges. Minimum maximum does not matter. Minimum maximum does not matter because you have a tree. Because you have a tree. Okay, so it does not matter minimum maximum. But if I ask you the same question for forest, if I ask you for the same question for forest, then the minimum will be 0 and the maximum will be n minus 1. Okay, so this type of forest will be a tree. Basically, this type of forest will be a tree. And this type of forest is basically your EN, edgeless graph on n vertices. Next, what is the answer for this question? Is it possible? Graph with 8 vertices, 8 edges, no cycles? The answer again is no. It is not possible because no cycle means forest. Okay, and in a forest, maximum number of edges, that always will be n minus 1. This is the maximum number of edges possible in a forest. Is it necessarily a tree? This question, is this necessarily a tree? Is it necessarily a tree? This question. Graph G with n vertices, there are n vertices, one vertex of degree n minus 1, rest of the vertices of degree 1. Is this necessarily a tree? You have a graph with n vertices, one vertex has degree n minus 1. So one vertex, let's assume this vertex is A. Let's assume this vertex is A. And the rest of the vertices have degree 1. Is this necessarily a tree? Yes, because tell me, one thing you tell me, this has n minus 1 vertices. What it tells you? This vertex has n minus 1 degree. What it tells you? This vertex has n minus 1 degree. What it tells you? So let's assume this is A1. If this has n minus 1 degree, then what it means? It means this is adjacent to all other. It means this is adjacent to all other. So you have a you have a graph with n vertices. There is a graph. You have a graph, and there are n vertices. You have n vertices. Let's assume A1, A2, A3, and so on, AN. These are your n vertices. Now, let us assume that this vertex has degree n minus 1. What it means? It means A1 is adjacent to all other. It means A1 is adjacent to all others, because this has degree n minus 1. Degree n minus 1 means it is adjacent to all other. So this A1, this is adjacent to all other, A2, A3, A4, A5, and so on, and so on, and so on, AN. So you can notice, yes or no? So this A1 has degree n minus 1. Automatically, every other vertex has how much degree? Automatically, you can notice that this is saying rest of the vertices have degree 1. You can see rest of the vertices have degree 1. You can see this has degree 1. You can see this has degree 1. You can see this is at degree 1. Every vertex has degree 1. So one vertex has degree n minus 1. Other vertices have degree 1. So what this means? This is your star graph. This is your star graph. And so every star graph is a tree. Every star graph is a tree because there is no cycle. We don't have any cycle. Every star graph is tree. See, every star graph is tree, but tree need not be star graph. For example, consider this tree A, B, C, D, E. This is a tree. This is a tree, but this is not a star graph. Okay, basically the question is saying that you have a vertex with a degree n minus 1 and all other vertices have degree 1. It simply means this is a star graph. Yes or no? It simply means this is a star graph. So is it necessarily a tree? The answer is what? Is it necessarily a tree? The answer is yes. Is this clear to everyone? There are n vertices, total n vertices we have. One vertex has degree n minus 1. So it simply means that this vertex is adjacent to all other vertices. Now you can notice all other vertices have degree 1, and this is what the question is saying. So finally I can say that this is the idea. Now tell me the answer for this question. A cyclic graph must have at least 3 vertices of degree at least 2. A cyclic graph must have at least 3 vertices of degree at least 2. Why this is true? Why this statement is true? This statement is true. Why this is true? You have a cyclic graph. See, if you have a cyclic graph, then what is the smallest cycle possible? In a cyclic graph, this is the smallest cycle possible. This is the smallest cycle possible in a cyclic graph. So for example, you can have this cyclic graph, you can have. Okay, you can have this type of cyclic graph, you can have this type of. Correct? So this is the smallest cycle possible. Now you can notice that if you have a cyclic graph, then at least 3 vertices have degree at least 2. This at degree 2, this at degree 2, this at degree 2. There can be more. For example, this at degree 2, but the idea is at least 3 vertices will have degree 2. Yes or no? Is this clear to everyone? A cyclic graph must have at least 3 vertices of degree at least 2, because the smallest cycle possible, what is the smallest cycle possible in a cyclic graph? If you notice the smallest cycle possible, that will be something like this, and you can clearly see that they have degree 2 to 2. Okay, this is the smallest cycle possible. So very simple. So you can notice in any cycle, if you have any cycle, in any cycle, every vertex has degree greater than or equal to 2. If you have any cycle, you can have this cycle, you can have this type of cycle. Whatever cycle you have in a cyclic graph, okay, for example, this can be your cyclic graph. Maybe this is your cyclic graph, whatever. So whatever cyclic graph you have, then this will happen. Okay, what about this question? Tell me, what about this? True or false? Consider a graph G such that at least one vertex is connected to all other vertices. At least one vertex is connected to all other vertices. Then such graph is not bipartite. This statement is false. Why this statement is false? This statement is clearly false. Why this is false? Star graph. This statement is false. This is saying that you have a graph G such that at least one vertex is connected to all other. At least one vertex is connected to all other vertices. Okay, like this type of graph is also you can have, but this is bipartite. This graph is bipartite. This is the counterexample. This is the counterexample, yes or no? So this statement is clearly false because the star graph will be the counterexample. Clear? What about this question? A graph in which at least one vertex is connected to all other vertices, and there is some other vertex. See, at least one vertex is connected to all other vertices, and there is some other vertex. Some other vertex of degree more than 1. This graph is not bipartite. What do you think? What is your opinion on this? Is this statement true or false? Consider graph G. You have this statement is actually true. This statement is actually true. Why? See, the question is very simple. There is at least one vertex V. So there is this vertex V. This is connected to all other. This vertex V is connected to all other. Now there is another vertex A. There is another vertex A. Okay. And this vertex A has degree more than 1. What it means? If this has degree more than 1, then what it means? Please tell me. If this has degree more than 1, then what it means? It means, for example, this type of thing will happen. This type of thing will happen. Correct? Yes or no? And now you have an odd cycle. Now you can notice there is an odd cycle. Now you can notice there is an odd cycle. So this is odd length, odd cycle. So not bipartite. Okay. So this is a simple question. GATE exam is all about these questions. This type of simple questions they will ask you. You just have to apply the question. The question is saying there is a graph. At least one vertex is connected to all other. So this vertex is connected to all other. This vertex is connected to all other. And there is another vertex which has degree more than 1. This vertex is connected to all other. This vertex is connected to all other. Now this vertex has degree. This vertex has degree greater than 1. It means this vertex is connected to someone. It means this vertex is connected to someone. So whatever you do, there will be at least one odd cycle. There will be at least one odd cycle. Yes or no? There will be at least one odd cycle. And so I can say that this is not bipartite. Is this clear? You know the theorem that, okay. So I can say graph is bipartite if and only if all cycles are even cycles. All cycles are even. Yes or no? Bipartite if and only if all cycles are even. This is the theorem. So bipartite if and only if no odd cycle. I can say bipartite if and only if all even cycles, all cycles are even. Now you can notice in this question, just think about it. In this question, there will be at least one odd cycle, right? You will have at least one odd cycle. So this is not bipartite. What about this question? This is true or false? G is a graph with at least 2 vertices. With no vertex of degree 1. G cannot be true. G cannot be tree. Is this statement true or false? This statement is true. We have already seen this in the last class, but let me tell you again what this is. G is a graph with at least 2. G is a graph with at least 2 vertices. Can G be a tree? Assume G is a tree. Is it possible? Assume G is tree. Assume G is a tree. Okay, assume G is tree. What it means? In this G, you have total n vertices, A1, A2, A3, An. If I assume G is a tree, then what it means? What is the degree of every vertex? Please tell me. What is the degree of every vertex? That is greater than or equal to 1. Because tree is connected, right? If you assume G is a tree is connected. Tree is connected. So because tree is connected, so degree of every vertex will be greater than or equal to 1. Now assume G is a tree, and the question is saying that no vertex of degree 1. No vertex of degree 1. Then tell me what is the degree of A1? Please tell me what is the degree of A1? No vertex of degree 1. Every vertex has degree greater than or equal to 1 in a tree because tree is connected. Because tree is connected. Okay, so this has degree greater than or equal to 2, degree greater than or equal to 2, degree greater than or equal to 2, degree greater than or equal to 2. Now what is the problem? Now what will be the problem? Now the problem is, now what is the total degree? Just see what is the total degree. Just look at total degree. The total degree will be what? That will definitely be greater than or equal to 2, and right. Every vertex has degree greater than or equal to 2. Greater than or equal to 2, greater than or equal to 2, greater than or equal to 2, greater than or equal to 2. So total degree will be greater than or equal to 2n. But total degree should be what? But in a tree, total degree should be what? But in tree, total degree should be 2n minus 2. Total degree should be 2n minus 2. And total degree is going greater than 2n. So that is a contradiction, right? Actually, total degree should be this much. Total degree should be this much. But your total degree is going more than 2, 1. more than 2n. So there is a contradiction, right? There is a contradiction. So what it means? It means G is not a tree. It means this assumption is wrong. It means G not a tree. It means G is not a tree. Now, is this clear to everyone? So this statement is true. If you have a graph in which you don't have degree 1 vertex, there is no degree 1 vertex, then it cannot be true. This statement is actually true. What about this question? True or false? G is a graph with at least 2 vertices with exactly 1 vertex of degree 1. Exactly 1 vertex of degree 1. This cannot be a tree. This statement is also true. Why this statement is true? Assume the same thing. Assume G tree. The same point. Assume G is a tree. And because you are assuming in this G you have these vertices A1, A2, A3, AN. These are your vertices. Because G is a tree, so it is connected. So it is connected. And so every vertex degree must be greater than equal to 1. For every vertex, degree must be greater than equal to 1 for all V. For all V. So what should be the degree? But remember, the question is saying that exactly 1 vertex has degree 1. Let's assume this has degree 1. Then what is the degree of A2? Tell me. Tell me what is the degree of A2? That is greater than equal to 2, greater than equal to 2, greater than equal to 2. Because exactly 1 vertex has degree 1. Exactly 1 vertex has degree 1. Exactly 1. Exactly 1 vertex has degree 1. So this vertex has degree 1. All other vertices have. So what is total degree? Total degree will be basically greater than or equal to 2 into n minus 1 plus 1. The total degree will be greater than equal to 2 into n minus 1 plus 1. 2 into n minus 1 plus 1. Okay, so the total degree is basically greater than equal to this value. If you notice this value, what is this value? This value is equal to 2n minus 1. So total degree is greater than equal to 2n minus 1. But in a tree, what should happen? But in tree, total degree should be what? Total degree actually should be this. See, this is saying that total degree will be greater than equal to this. Total degrees will be greater than equal to this. But in a tree, total degree is this. So there is a contradiction. Again, there is a contradiction. You are saying that total degree will be greater than equal to 2n minus 1. But the total degree should be 2n minus 2. So there is a contradiction. Again, there is a contradiction. Because there is a contradiction, so not true. So G not a tree. So finally, I can say yes, G cannot be tree. Yes or no? So this statement actually we have already seen. So this is the final note. What is the final note? Every tree with at least 2 vertices, okay, every tree with at least 2 vertices has at least 2 leaves, leaves means. And what is a leaf? Leaf is a degree 1 vertex. Okay, so very simple. Pendant vertex, yes. So every tree with n greater than equal to 2 has at least 2 leaves, or I can say pendant vertex. Okay, I can say this is basically your pendant vertex. At least 2 pendant vertex will be there. What about this question? True or false? In a tree, if we add an edge between 2 existing vertices, it creates exactly 1 cycle. Will you get exactly 1 cycle? It will create exactly 1 cycle. Will you get exactly 1 cycle? Tell me, will you get exactly 1 cycle? If you add an edge in a tree, the statement is true. Yes, this statement is true. Because see, if you have a tree, you have some tree. For example, maybe this tree you have A, B, C, D, E, F, G, H, If you add one A's, then what will happen here? If you add one A's, then how many cycles you will get? See, if you add one A's, you will get a cycle. If you will get a cycle, if you add, for example, if I add this A's, then I will get a cycle of length 5. If I add this A's, cycle of length 5. If I add this A's, cycle of length 3, cycle of length 4, cycle of length 3. If I add this A's, cycle of length 3, cycle of length 3, cycle of length 4, cycle of length 3, cycle of length 5. But how many cycles I will get? If I add one A's, then how many cycles I will get? I will get exactly one cycle. So in a tree, if I add one A's, then I will get, remember, I can say that tree plus one A's. Okay, tree plus one A's. That implies, okay, cyclic graph with exactly one cycle. Cyclic graph with exactly one cycle. Okay, so this is idea. This is the idea. Very simple. Now tell me about this question. True or false? This statement. To a tree, if we add a new vertex with one edge, it creates a cycle. It can create 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 a cycle. Can it create a cycle? It can create a cycle. The statement is false. See, if you have a tree, if I give you a tree A, B, C, D, okay, if I give you a tree, this type of tree I give something. Now, what you do? You add one more vertex. You add one new vertex with one edge. With one edge. You add this vertex with one edge. Can you get a cycle? Can you get a cycle? In a tree, if you add one more vertex with one edge, you add one more vertex with one edge, you will again get a tree. You can never get a cycle, right? Okay, so in a tree plus one vertex, one new vertex with one edge, one new vertex, one new vertex. Okay, remember tree plus one new vertex of degree 1. I can say this. I can say this. One new vertex of degree 1. This implies again a tree. This implies again a tree. Yes or no? Another new tree you will get. So tree plus one new vertex of degree 1 is equal to 2. Actually, this point is very important. Why this point is important? Let me tell you. When you study algorithms, let me tell you this point here. When you study algorithms, there is something called minimum spanning tree algorithms. There is something called MST. This MST topic you will study, minimum spanning tree. There you will see two algorithms. You will see one is Prim's algorithm, and so there are two algorithms, Prim's algorithm, and there is a Kruskal algorithm. Okay, these things you will study. Now let me tell you that in Kruskal, what you do, in Kruskal actually you have a tree and you add one edge. This Kruskal is basically based on this concept. You have an intermediate tree. There is an intermediate tree. There is an intermediate tree, and in that tree you add one more edge. Add one more edge. Okay, so this is the this is the idea. You have intermediate forest actually. Sorry, you have intermediate forest. So there is intermediate forest, and to that intermediate forest you add one more edge. So if you do this, then cycle can come or not? Is it possible that cycle can come? Intermediate forest is there, and if you add one more edge, cycle can come or not? Cycle can come or not? Are cycle can come, right? If I give you this intermediate forest you have, this intermediate forest you have, if I add one more edge, for example, let's assume this is your intermediate forest. Let us assume this is your intermediate forest. If I add one more edge, cycle can come, right? Okay, yes or no? So in algorithm subject, you will study MST. There are two algorithms you will study for MST, for minimum spanning tree. These two algorithms you will study. What this will do, This will do that there is an intermediate forest, and to that intermediate forest you will add one more edge. So if you do this, then cycle can come, yes or no? Cycle can occur. Cycle can occur, yes or no? Cycle can occur. Agree? Because you can notice if you add one more edge, cycle can occur. If you add one more edge, then cycle can occur. In Prim's, what you do, in Prim's algorithm, what you do, there is an intermediate tree. There is an intermediate tree. In this algorithm, what is there? There is an intermediate tree, and to that intermediate tree, you add one vertex with a degree 1. One new vertex with a degree 1. One new vertex with a degree 1. Okay, this is what you do. Like one new vertex you add with one edge. With one edge. So now tell me, if you do this in a tree, if you add one more edge, okay, like here. So this is what happens in Kruskal. This is what happens in Kruskal. But in Prim's, tell me, in Prim's algorithm, you have an intermediate tree. There is an intermediate tree. Like for example, you have this tree A, B, C, D, something. Then tell me, if you add one more vertex, cycle can occur or not? So there is an intermediate tree. In that tree, if you add one more vertex, cycle can occur or not? Cycle can never occur. So in Prim's algorithm, cycle can never occur. In Prim's algorithm, I can say cycle can never come. Cycle can never come in Prim's algorithm. So I can say here in Prim's, cycle can never come. This is important. Cycle can never come. Why I am telling you this is important? Because actually I have seen many teachers, many teachers, what they do, they teach this Prim's algorithm in a wrong way. Okay, many teachers, you can study like, okay, if you watch like not in Go classes, but if you watch some other video on YouTube or maybe on some other coaching institute, then they will teach this Prim's algorithm in a wrong manner. In Prim's algorithm also, what they will do, they will somehow create a cycle. Okay, they will somehow create a cycle. Okay, so anyway, what I'm saying that this is the idea of Prim's algorithm, and this is the idea of Kruskal algorithm. In Kruskal algorithm, cycle can occur, but in Prim's algorithm, cycle can never occur. Okay, anyway, don't worry about it. This you will study in the algorithm subject. Now let's not worry about it. Now tell me about this. But when you study this in the algorithm, at that time you can remember this. Okay, this point you can remember that Deepak sir had taught. Okay, you can just say at that time you can tell Sachin that Deepak sir has taught. Okay, now, so tell me what is the answer for this? True or false? If G has no cycles, so it means what is G? Tell me what is G? If G has no cycles, what is G? G is forest. G is forest. Array, G is not tree, G is forest. Array, G has no cycle, it means G is forest. G is not tree, G is forest. Okay, so if G has no cycles, it simply means this is a G has no cycles, it simply means this is a forest. G has no cycles. Okay, it means G is a forest. But by adding one edge between any two vertices, okay, between any two vertices will create a cycle. It means this is a tree. Can I say? Tell me this question. Does it mean this is a tree? True or false? For example, if you take this forest, like let me give you a forest like A, B, C, D, E. If you have this forest, now in this forest, by adding one edge between any two vertices, see, this is important. This is important. Between any two vertices, see, this is a forest. If I add this edge, cycle will come. But between any two vertices, this line is important. Remember, this line is important. This statement is important. Between any two vertices, this statement is important between any two vertices. So you can notice this is your forest. Now in this forest, if I add here, then the cycle will not come. Okay, plus any edge, like, okay, this is important, like plus any edge, And okay, you can notice that if you add one more edge, then cycle may not come. So it should be a tree. Okay, so finally it should be a tree. It should be a tree. Okay, so the answer is G is a tree. Yes. So this statement is true. Okay, such forest must be a tree. Next. Okay, so next, what about this question? G is a connected graph. Then G is already a connected graph. Now G is tree if and only if no cycles. G is connected graph. G is a tree if and only if no cycles. So this statement is also true. This is the definition of tree, because tree is basically connected and no cycles. Next, what about this statement? T is a tree. G is a new graph by adding vertex X and connect it to one vertex through an edge in T. Then G is a tree. This we have already seen. This we have already seen. This is true. Okay, because basically what you are doing, T plus new vertex, tree plus new vertex. You have a new vertex. Okay, and you are adding through one edge. Okay, so tree plus new vertex with one edge, with one edge. So that or another tree, you will again get a tree. We have already seen. Next, what about this question? Quickly tell me, true or false? Adding one edge to tree creates exactly one cycle. Yes, this is true. Next, what about this statement? Every tree with n greater than equal to 2 vertices has at least 2 vertices of degree 1. This statement is also true. Okay. Next, this statement. Yeah, this statement is interesting. So tell me, a finite graph in which every vertex has degree greater than equal to 2, then it has cycle. A finite graph in which every vertex has greater than equal to 2 degree has a cycle. This statement is also true, because you know that if you have tree or forest, if you have tree, okay, if you have tree with n greater than equal to 2, then definitely what will happen? Then definitely at least 2 vertices will have degree 1. At least 2 vertices have degree 1. Have degree 1. Okay, so if every vertex has degree greater than equal to 2, if every vertex has degree greater than equal to 2, then it has a cycle. Yes, this statement is correct. Next, removing any one edge from a tree results in how many trees? Removing any one edge, if you remove one edge, then how many trees you will get from a tree? You have a tree, you remove one edge, then you will get exactly two trees you will get. You will get exactly 2 trees. Yes or no? You will get exactly 2 trees. For example, if you have a tree, this is your tree, A, B, C, D. Okay, this is your tree, E. Now, if you add, if you remove any one edge you remove. For example, if I remove this edge, then I will get 2 trees. If I for example, if I remove this edge, then I will get this tree and I will get this tree. So you will get 2 trees. This is your TIFR question. What is the answer? Which of the following is not a sufficient and necessary condition? Sufficient and necessary condition, what this means? Sufficient and necessary, what this means? This means sufficient and necessary. This means definition. Sufficient and necessary means definition. So which of the following is not a definition? Sufficient and, that is a definition. Definition means if and only if. Okay, so tell me, which of the following is not a definition for undirected graph to be tree? So is this the definition? Statement E. This is not the definition. This statement E is not the definition. So the question is asking which is not a definition. So yes, this is not a definition, because this is not a definition. For example, you can have this graph. This graph you can have here n equal to 4 and number of edges equal to 3. Okay, so this is definitely, this is not a definition. Statement E. Acyclic connected, this is enough. This is enough. Acyclic connected, this is enough. Connected n-1 edges, this is enough. Acyclic n-1 edges, this is enough. So the answer will be option E. Option E is not a definition. Is this sufficient or necessary? This statement E, this is sufficient or necessary? This is necessary or sufficient for tree? This is necessary for tree, not sufficient. This is necessary for tree, not sufficient. Not sufficient. Okay, this is necessary but not sufficient. Okay, solve this question. So how many edges in a forest? If you have a forest with n vertices, k components, then how many edges will be there? So you have this forest, you have, okay, you have a forest in which you have k components. Like k components, you have g1, g2, g3, gk, total k components you have. This is a forest. Forest means this g1 is what? Tell me one thing. This is what? This g2, this g3, this is what? This is tree. This is tree. This will be tree, because in a forest every component is a tree. So this is a tree. So this is a tree. Now let us assume that number of vertices. Let us assume number of vertices here is n1, here n2, here n3, and here nk. Then tell me what will be the number of edges. Tell me what will be the number of edges. So that will be n1 minus 1, that will be n2 minus 1, that will be n3 minus 1, and so on, nk minus 1. Because this g1 is tree, g2 is tree, all these things are tree. In a forest every component is a tree. In a forest, k connected components. In a forest everything is tree. So basically k trees. Basically you have total k trees, because in a forest every component is a tree. So now what is the total number of edges? Total edges, total number of edges, total number of edges in forest. Total number of edges in forest, what that will be? That will be, just add all of them. Just add all of them. So I can say n1 plus n2 plus nk minus k, minus k, because see this, that will create minus k, and this plus this, so this will create, what is this value? What is this value? This value is n, total number of vertices. So the answer will be n minus k. Is this clear? Is this clear to everyone? How many edges will be there in the forest? So in the forest, number of edges will be n minus k. If you have k components, remember in forest every component is what? In forest every component is a tree. In a forest every component is a tree. Now, so I can say that if you have k components, then number of edges will be n minus k. Very simple, because you have k components. These are the k components. I am assuming that these are the number of vertices. Then because every component is a tree, so number of edges will be this. In this component, number of edges will be n2 minus 1. So if you add all of them, then how many edges are there in the forest G? You have a forest G. So in the forest G, how many edges will be there? That will be this plus this plus this plus this. So finally I will get n minus k. Okay, tell me, if k is equal to 1, if k equal to 1 means number of components equal to 1, then number of components equal to 1, then forest is same as tree. Yes or no? If you have only one component, it means this is a tree. If you have one component, then it will become a tree. And if you have k equal to 1, then number of edges will be n minus 1, because you can put k equal to 1. This k equal to 1 you can put. So if you have k equal to 1, then forest will have n minus 1 edges, because if you have one component only, if there is only one component, it means the forest is a tree. Yes or no? It means the forest is a tree. So in a tree, these many edges you have. Is this clear to everyone? Tell me. This is GATE 2014 question. What about this question? GATE 1995. What will be the answer? The minimum number of edges in a connected cyclic graph. Connected cyclic graph. So the answer will be n. Next, connected cyclic graph. The question is asking about connected cyclic graph. We have already seen. This is GATE 1993 question. What is the answer? Simple connected graph you have with n vertices, and there are n edges. Which of the four n vertices, n edges? n vertices, n edges, and connected graph you have. Connected graph, n vertices, n edges. Then it means there is definitely cycle. Definitely you have at least one cycle, right? So G has definitely at least one cycle. G will definitely have at least one cycle. Okay. Yes or no? Can I say this graph has at least one cycle? Can I say this graph has at least one cycle? Can I say G has at least one cycle? Can I say G has at least one cycle? Yes. If you have exactly one cycle, then it automatically implies you have at least one cycle. If you have exactly one cycle, it automatically implies you have at least one cycle. You have at least one cycle. But at least one cycle does not imply exactly one cycle. Okay. So here you can notice you have a connected graph, n vertices, n edges. Connected graph, n vertices, n edges. It means definitely there is a cycle. And remember, the graph is connected. Okay. So definitely you have a cycle. And the question is saying the graph obtained by removing any edge form G is not connected. Is this statement true? Statement B is not true. Consider this graph A, B, C, D. Consider this graph. If you remove any edge, if you remove any one edge, if you remove any one edge, then what we will get? If you remove any one edge, then also we will get a connected. Okay, so the graph removing any edge is not connected. So this statement is definitely wrong. G has no cycle, wrong. The graph obtained by removing any two edges is not connected. The graph obtained by removing any two edges from G is not connected. Yes, this statement is also true, because if you remove two edges, so you have a connected graph. You have in a connected graph, you have n vertices, n edges. If I remove two edges, then it is not connected. Yes, it will not be a connected graph, right? If you remove one edge, then it can be connected. But if you remove any two edges, then it is not connected. N vertices, n minus 2. So it cannot be connected. Yes, this statement is also true. So G has at least one cycle. This is also true. And so yeah, so both these statements are true. Okay, option C, option D, both are true for this question. Because see, let me tell you, if you remove any two edges, then what will happen? You have a connected graph. You have a connected n vertices, n edges, n vertices, n edges. If you remove two edges, then tell me what will happen? If you remove two edges, then what will happen? Then you have n vertices, n minus two edges, n minus two edges. Can this be connected? Tell me. Can this be connected? Can it be connected? Can it be connected? The answer is no, because the minimally connected graph has n minus 1 vertices. Remember, minimally connected graph has n minus 1 edges. You know this. Minimally connected graph has n minus 1 edges. Okay. So both these statements are true. What about this question? This is GATE 2004. What is the maximum number of edges in acyclic undirected graph? So that will be a tree. Acyclic graph, maximum number of edges. So that is a tree. So these are the questions on tree. Are all of them clear? I have taken all the questions. All the questions that I found on the internet related to tree, which are GATE relevant, all the questions I have taken, and these are the questions. Okay.